Hi everybody, it's Hank McConnell with M&M Systems. Today I wanted to talk a little bit about condenser wet bulb control and what it means to the system. First thing is for energy management purposes, lower your energy costs, you want to run a lower head pressure. You want to run it as low as possible all the time. Here's a great example. One of our compressors at minus 15 degrees suction at different condensing temperatures, corresponding pressures, you can see that the brake horsepower per ton goes down as the condenser pressure is lowered. Therefore, the efficiency from like the 90-degree point, goes up. Screw compressors like it when the head pressure is low. They run much more efficiently, so that's what you want to try to do. There's two factors that can go with how far you can go. The primarily ones are the ones, the process and facility requirements that talk about defrost, oil cooling, thermal expansion valves. Another one to think about is the oil separator size. As the head pressure goes down, the velocities in the separator go up. So you might get some oil carryover if you get small separators. So it's something to consider. The best thing to do is to start working it down to see how low you can go before you start having problems, because you want to run as low as possible. So 100 to 120 certainly seems to be achievable in facilities that we see. The other factor, of course, is the ambient conditions. When it's hot outside, you can't do much. You can only do so much. So, I mean, with an evaporative condenser, the best possible head pressure, lowest possible head pressure you can expect is that which corresponds to what the wet bulb temperature is minus or plus an offset from the condenser approach temperature. So that's as low as you can go. You can't get any better. The ambient conditions won't allow it. That's what the liquid temperature is going to be, and therefore that's what the minimum head pressure is going to be. So the problem then becomes is that you want to run as low as you can to save energy in the engine room, but by trying to do that, you might be wasting energy on the roof because you're at ambient conditions that won't allow it to happen. So the solution to that is wet bulb control. It's got a bunch of different names. We call it wet bulb control. Others can call it floating head pressure control. And what that does is it automatically adjusts the condenser set point based off what the ambient conditions are. So it takes the wet bulb temperature plus the approach temperature and then back computes that into a saturated pressure. And then that now becomes your set point. And it works great. In the cold, though, the wet bulb temperature, when it's cold outside in the winter, can drop really low. So therefore, you need to make sure that you have a lower level limit so that you don't go below what your process or facility requirements are. So what it will do is that as the ambient conditions are such, it won't allow you to waste energy on the roof in order to be able to try to lower your head pressure. So here's an example. 80 degree Fahrenheit ambient, 73% humidity. Wet bulb would result into 75.1 degrees Fahrenheit. Approach temperature 10 degrees on the condenser, and that's what we see. You can look it up, talk to your condenser manufacturer, or in 9 degrees is what typically it sees. And then so therefore the lowest possible saturated liquid temperature would be 85.1 degrees Fahrenheit. Resulting in condenser pressure, if we look it up on the chart, would be 151.4. So therefore we would set the set point to 151.4, and that's what you try to control to. Here's a great example off of our dashboard as to how that works. I mean, here's one that's using it, and you can see the red is the set point, and it adjusts as the ambient conditions adjust. A lot of times you'll see it flatline in the middle of the night to the low setting because it's cool conditions, and then go up as the sun comes up and starts to warm up outside. Now, something to really consider is now that two temperature sensors, your ambient temperature and humidity, which oftentimes you just use for monitoring purposes, now becomes super critical to the process, and it's important that they read accurately all the time. So you need to make sure that their location is correct. They need to be clear of any exhausts or intake. They need to be out of the sun. They need to be out of other elements. The north side of the building, under an eave. You got to be also careful about radiant heat from other things. I had one mounted to the side of a building. Every day the metal building heated up from the sun, it would cause the temperature to go up. Now it becomes very critical because as the ambient temperature would increase, so would the condenser set point, and when you could possibly be running a lower head pressure, the control would set it higher. So it's very important now, then, if you're using wet bulb approach, to check your ambient and humidity sensors to make sure they're reading properly, just by verifying them with local weather reports and doing it multiple times in a day. And it's something that you want to keep on top of and make sure that you're reading right. Hey, I hope this helps. If you've got any questions, you can email us at mmsysinc.com, and also check us out on our webpage. And thank you very much.